Hi, I'm James, and this is
Quinn.
and we built a compact chimney climber in Mr. Steenstra's robotics class, and Quinn's going to explain a little bit of how it works.
Alright, so we built this using the NXT kit and the NXT 2.0 Discovery book from LEGO Mindstorms. This robot, the compact chimney climber, is featured in that book. So the way it works is this motor in the center turns on, raising these arms, and then once they are raised, these motors turn on, spinning the wheels, which are meant to bring the robot up the wall. Once the robot reaches the top, this ultrasonic sensor right here tells the robots at the top, tells the wheels to spin the other way and return to the ground, returning the robot. If the robot at any time becomes off balance, this right here is a color sensor that we use for a balance sensor. Should tell it to get back on track. If it tilts this way and it sees black, it'll tell the one wheel to stop so the other can catch up, and vice versa if it tilts this way and sees white. So we're going to show it to you now. So it's slowing down because it has to get back on track for height. Then my note card's going to be the ceiling so it doesn't run off track. That just sensed the ceiling and it told the robot to return to the ground. And that's it. It's a robot.
Hi, my name is Garrett Senti.
And I'm Nathan Lopez, and this is our robot called Tilted Twister, which solves the Rubik's Cube.
Our robot, we built it following the instructions from this website called Tilted Twister, and our robot is complex in a sense, and we didn't have time to actually design our own program, so we just borrowed one from the computer. But I'm going to explain the different parts. We have 3 motors, which one is to move the cube, another is to move the light sensor over the cube and scan the colors, another is to move the arm and to hold it in place. There's the ultrasonic sensor, which tells if the cube is on the robot or not. We have the light color sensor, which scans the colors of the cube and uses that to solve the cube. And then we have our touch sensor, which basically starts our whole program once it touches right here. So without further ado, we'll start our program.
Hi, I'm Caleb. Hi, I'm Soo-Young Park, and we are going to show you our robot called Ball Shooter.
Our robot is a ball shooter that is controlled by a light sensor right here. The robot uses that light sensor to sense a light, and then using that data, it shoots at the target. It's got three main points. It's the motors, light sensor, and then the ball shooter. There are three motors. Two control the shooting action, right here, the shooter right there, and then this one here controls the shooting motion, which makes the ball shoot. And so the robot, before it shoots, it moves around and looks for a target. It starts here in the center, and then it moves over here to the left, where it takes, in the middle here, it takes a reading of the amount of light that is being produced. And then it moves over here to the left, reads the amount of light coming from the left, and then moves over to the right and reads the amount of light coming from there. After it's done all that, it then determines which location had the most amount of light and goes to that location and then shoots. So now we will demo it, and here we go. And the robot's programmed to shoot at this light, and so it doesn't always hit the target, because the robot is not being told the target is the target. This light is the target.